All right, on this video here, we're going to be talking about lesson 7.5, which is graphs of other trig functions. So in the last video, we specifically just talked about sine and cosine because those are typically your main ones, but there are 4 other trig functions. So we'll kind of talk about all of those real quickly. Right? So we have tangent. And just like with the sine and cosine, there's really just 5 main points. So our 5 key points here. And again, the textbook, if you want 16 different points, they'll definitely give it to you. But 5 key points are 0, 0, pi halves, comma, undefined, pi, comma, 0, 3 pi halves, comma, undefined, and 2 pi, comma, 0. Couple things to note. The period for a tangent is only pi. All right, so graphically what this looks like is we have a coordinate at 0, 0 at pi halves. Call this pi, 3 pi halves, and this 2 pi. We'll pretend they're all evenly spaced. All right, so what that means is there's actually an asymptote at pi halves. It goes through at pi. There's an asymptote at 3 pi halves. And then there's it goes through 2 pi. And what that is basically your tangent functions look like a whole bunch of cubic functions. So kind of like this. Technically, if we call this negative pi halves, and then it goes like this. Again, it goes really close to these asymptotes, but then never really crosses them, just like this one. And then again, if I was to extend this and call this 5 pi halves, pretend that line was straight too. All right, so basically that is why it says that a period is a pi, because it repeats every pi. So it has these asymptotes and then like a cubic function inside, and then that would be one period, and then it repeats itself. All right, but those are your 5 key points. So really, again, on the homework, you're really just picking the correct graph that goes with each function. And then we have cotangent, our 5 key points here are kind of like the opposite. It basically looks like it just shifts over. So it's actually 0, undefined. And then pi halves, comma 0, pi, undefined, 3 pi halves, comma 0, and then 2 pi, undefined. And again, the period of a tangent is just pi. Sorry, of cotangent. All right. And so what we see here, very similar to tangent, except now I have a vertical asymptote at the y-axis. We'll say this is pi halves. We'll say this is pi. We'll call this 3 pi halves. And we'll call this 2 pi. And then at pi halves, we have it at 0. At pi is another vertical asymptote. 3 pi halves is at 0. And then 2 pi is also undefined. Now, so it makes the same concepts, but with a cotangent, it actually mimics a negative cubic function. So that means it just goes like this. And then just kind of repeats itself every pi period. Right? And so that's a cotangent function. The next up is a cosecant or secant. I don't really matter. We'll do cosecant because I said that first, but it doesn't matter. Our 5 key points. We have 0, undefined. We have pi halves, comma 1. We have pi undefined. We have 3 pi halves, -1. And then we have 2 pi, which is undefined. So the function here basically means at 0, we again have a vertical asymptote on the y-axis. At pi halves, so at pi, we have it at 1. At pi is undefined. 3 pi halves is at -1. And at 2 pi is undefined. So what cosecant and secant, they make a whole bunch of quadratics. So we have a quadratic here, then we'll have a quadratic here. And then it would just keep repeating. So here, the period is back to 2 pi, because at this point, it would then go back up here and so on and so on. So this will be a full period for a cosecant. It basically just has 2 quadratics. All right, the last trig function you need to know is secant. So our 5 key points are 0, 1, pi halves, comma undefined, pi, comma -1, 3 pi halves, comma undefined, and 2 pi, comma 1. So just to give you an idea here on why it's like this, for a sine function, this is not part of the graph, but just so you can see it, this is what a sine function would do. Right, this is sine. Right, so you can see since cosecant is the inverse of sine, the x and y values are changing. So at the height of a sine function and at the minimum of a sine function, this part here infinitely goes in this direction. So it's like it reflects right there at the max and min. All right, so same kind of concept when we're talking about this right here. Again, the period is still going to be 2 pi. So to give you an idea here as well, we have it at 1. We have it at pi halves. That's undefined right here. Pi is at -1. 3 pi halves, undefined. And then 2 pi is at 1. So when you're graphing it, let's say this is negative pi halves. Technically, you'll do this. We'll do this. So it looks very similar to cosecant, but just shifted. But again, you can see from here to here, it then starts repeating. So that's why the period is 2 pi. But once again, this is what the cosine function did. Right? This is the cosine function, so you can kind of see. Again, it's the inverse, so it just again reflects this at its max or min value. So it goes up as if it was going down. All right, so those are your other 4 functions. So now you have all 6 functions. And on this homework, all you have to do is match the graphs, or at least that's all I saw. So let's do a whole bunch of different ones. So let's look at number 4. So this is f of x equals -5 cotangent of pi x. So recall a couple of things. This is my A. This is my B. Remember the A, you multiply the Y. My B, you multiply the inverse to your X. All right, so we start with our old points for cotangent. So remember, cotangent was 0 undefined, pi halves, comma 0, pi, comma undefined, 3 pi halves, comma 0, and 2 pi, comma undefined. All right, for our cotangent. So our new points, I need to multiply my x value by 1 over pi. So this would mean I need to do 1 over pi times x. So this would be 1/2 times 0, or 1 pi times 0 is 0. Undefined cannot change. The only time that the asymptotes move is if there is a phase shift. And again, to do phase shift, remember it's C divided by B. And remember this right here would be the plus C if there was one. So this is 0 divided by pi, which stays 0. And remember that you would add to your x value. Right? And then if there was a plus K, remember we would add that to the y value. All right, so here we go. So again, pi halves times 1 over pi would basically just be 1/2. 0 times -5 would just be 0. And then we kind of go through that same process. So this would be 1 undefined. This would be 3/2, 0. And then this would be 2, and then undefined. And then we just got to pick the graph, the correct graph. So if you recall, at 0, we have undefined. And then now we don't have these pi's, so I'm just going to do these by halves. You want to look at your x-axis and see which one has the correct markers. And then see, it says sketch the graph. It doesn't say how many, so you just pick the appropriate one. So again, at 1 is undefined. And then 2 would be undefined. And then we have these values here. Now here is the kicker. When A is negative, remember it will reflect across the x-axis. So instead of it going like a negative x cubed, it will now look more like a tangent function just because this is negative. So remember, if A is negative, reflect across x-axis. And I don't remember if we dealt with something like that on the last lecture, but it is now on this lecture. So I definitely want to make sure I highlight that if I didn't in the last one. And there you go. And so you would just go find that graph, and there you go. I don't think you had to graph any of them. You just had to pick the correct one. So again, a pretty easy homework compared to what I get. So I have to kind of graph it for you. All right. So let's do a few more, and then it'll pretty much be the end of this lecture. So let's look at number 5. G of x equals cosecant of 3 pi over 2x minus 1/2. Again, start with your old. Cosecant, again, was 0, undefined, pi halves, comma 1, pi, comma undefined, 3 pi halves, comma -1, and then 2 pi comma undefined. Do the new, but make sure we label it appropriately. This is my B. My A has a value of 1. And this is my C. So my A is 1. I would multiply that to my Y, but I don't have to do anything. My B, I would take the inverse of this. So this would be 2 over 3 pi times my X value. My C is part of my phase shift. So this is going to be negative 1/2 divided by 3 pi over 2. So we do negative 1/2 times keep, change, flip. So this gives us negative 1 over 3 pi. So that is what I would need to add to my X value. All right. I have a good feeling it's going to be some wonky numbers. Oh, sorry. There we go. Um, okay, so here we go. So my X, I would multiply 0 to 2 over 3 pi. So that would just give me a 0. Oh, sorry. And then add the negative 1 3 pi's. But remember that this means shifts right. So I actually want to add a positive 1 over 3 pi. So this would be 1 over 3 pi, comma, undefined. All right, and then we kind of keep going. So pi halves, we'll do some side work here. So pi halves times 2 over 3 pi. Pi's would cancel, 2's would cancel. So this gives me 1/3 and 1 over 3 pi. So this would be the same thing as pi plus 1 over 3 pi, because that's what this would be. I would just multiply both of them by pi to make them the same denominator. So I get pi plus 1 divided by 3 pi, comma, again, there's nothing to multiply to the y value, so it'll just remain 1. And then this one, again, doing some side work, that'd be pi times 2 over 3 pi, which would just give me 2/3. And then I need to add the 1/3 pi. So again, that would give me 2 pi plus 1 over 3 pi. And then this would stay undefined. Yeah, sorry. Brain somewhere else. Not pi, sorry. That would be, I just did that one. This would be 3 pi halves times 2 over 3 pi. So it would just be 1 plus 1 over 3 pi, be pi. So that would be 3 pi plus 1 over 3 pi. So again, 1 would be the same thing as 3 pi over 3 pi. So this again will give me, and you can kind of see a pattern here. Basically shift it to the right, 1 over 3 pi. Negative 1 remain the same. And then you could do this work again. Hopefully you see the pattern. This is 4 pi plus 1 over 3 pi, comma, undefined. So when trying to pick out the correct graph, we want to see really and truly what is 1 over 3 pi. So let's do 1 divided by 3. I don't know how to make that correct in a calculator. Let's put that in parentheses then. Let's try that again. So 1 divided by, we'll open up a set of parentheses and say 3 times pi, because I definitely want that to be done first. So it comes out to about this right here. It comes out to be about 0.106. So it's going to look pretty darn similar to a regular cosecant. Um, and I think on y'all's homework, it actually went by numbers. So, so I think it actually on your homework, it went like kind of like this. Oh, give me a second. All right, so it actually went by one. So it actually went 1, 2, 3, 4, 5. That made it one. 1, 2, 3, 4, 5. That made it two. So basically, this was a point two. So therefore, there would be a undefined line about halfway around here. So that's what it decided to do. And then you can kind of go from there. So then basically just add this number to 1/3. So just say plus 0.3 repeating. Oh, I gotta write it over here. So okay, so plus 0.3 repeating. We'll put a whole bunch of them. And again, that gives you about 0.439. So here's 2, 4, 5. So about right here. There we go. And then the next one, if we just add 2/3 to that, so that another third basically. So we're gonna just go point or plus 0.3 repeating. That gives us about 0.7. So that's gonna be again 0.2, 0.4, 0.6, 0.8. And there'll be another one right there. All right. But it's almost like right on it. So it's like 0.7728. So it depends on how you do it there. And then there wasn't a point there. I meant to put that at +1. And then we just got to do it a couple more times. So we'll just add another 0.3 to this. And we get about 1.1. So here's 1. So then here's -1 right here. And then if we just add another 0.3 to that, this gets us about 1.4. So again, that's 2, 4, a little bit past this, about right here, give or take, will be another one. So I usually do at least one period. Your homework might have two periods graphed, but you're just looking for those key points, right? So again, this is just an observation one where you just pick the correct one. All right, so that gets a little harder when you have some weird numbers going there. All right, but I definitely want to make sure y'all saw one like that. Let's look at number 6. So here's g of x equals cotangent of pi-4 x. So remember, make sure we label our stuff. So I don't have an a, I just have a b. So all I have to do is take 4 pi and multiply that to my x, because that's the inverse, right? Oop, did a pi. And then that's it. There's no phase shift. There's no vertical shift. So I take my old points for my cotangent, which remember are 0, undefined. This would be pi halves, comma, 0. This would then be 3 pi halves, comma, undefined. This would then be 0 pi halves. This is just pi, my bad. This would be 3 pi halves, comma, 0. And then this would be 2 pi's, undefined. All right, so again, we take our graph. Oh, nope, I got ahead of myself. Let's find the new points. So again, all we got to do is multiply our x. So 0 times 4 pi is going to be 0 and then undefined. This would then be 4 over 2, so that's going to be just 2, 0. This is going to be 4, undefined. This would be 6, 0. And then I can kind of see a pattern already. And this would, again, be 8, comma, undefined. So nice little numbers here. So when I'm looking for these, I can say, all right, the vertical asymptote should be there. I'm going to actually go by, let's make sure I know what your homework did. And it went by ones. All right, so 1, 2, 3, 4, 5, 6, 7, 8. All right, so therefore at 2, I got a 0. At 4, I have an undefined. At 6, I have a 0. Then 8, I have an undefined. So again, I'm trying to keep it like your homework on what they went by. Here they again with a cotangent, it has the likeness of the negative x cubed, and there's no a to reflect it, so it would look a lot like this. And there you go. All right, let's look at a more challenging one. Let's look at number 7. This is f of x equals 5 tangent of 3 pi minus pi halves x. All right, so let's label our stuff. This is my a, which will be 5 times my y. This is actually my c, and this is my b. So my b, I would take 2 pi times my x, but for my phase shift, this would be 3 pi divided by pi halves, which would be 3 pi times 2 over pi. So that becomes 6. But it is technically a negative. Oh, but the b is negative. That would reflect across the x-axis. So we'll, I don't think that's going to affect your phase shift. Let's see. So if I go over 6, yeah, I don't think that's going to affect that at all. Better. It's going to be negative, so it actually will go right 6. But remember, it can go right or left, and you won't see the difference here. But we can go with that. So this would be added to my x value. There is no y. So my old for my tangent is 0, 0. Pi halves undefined. Uh, pi 0, 3 pi halves undefined, and then 2 pi 0. My new points. So again, I would take 2 pi times 0, which is 0, and then I need to go right, so I'd add 6. So this would actually take me to 6. And then for my y, I just need to multiply by 5, and it's 0. So again, pi halves times 2 over pi would just give me 1. 1 plus 6 gives me 7. Pi, again, would give me 2 plus 6, which is 8. That's oh, sorry, this would be undefined. This would be 0. Then it'd be 9 undefined because I can see a pattern now. And then this would be 10, 0. So when I graph this, go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go to 6. 1, 2, 3, 4, 5, 6. And I have a 0. 7's undefined. 8's a 0. 9's undefined. 10 is 0. And so then when I reflect this, so again, tangent typically goes like this. But because of this negative right here, it actually reflects across the y-axis. And what's nice is that these and this one, it looks like the same reflection. So this ends up actually looking more like a cotangent because when it's reflected across the y-axis, it looks just like as if it was reflected over the x-axis. And then, of course, this would go like this, and then this would go like this. All right, so now here's the issue on the test. It might not test the homework. It might not have this section. So, but you can see the rest of the pattern, right? Right. So I can kind of finish out this pattern. So whatever section of the graph it wants to give me as my option, I'll be able to easily go, all right, I need something that's going to be between 1 and -1. I'm going to need something that's going to be between 1 and 3. I'm going to need something and so on and so on. Right. So even though the section that we graphed wasn't part of the answer choice, you can finish off the graph to find the section. Because I want to say we graphed this part here, but this part is what the answer choice gave me. And so if I only have this section right here, I'm like, well, none of these, but you got to finish the pattern to see which one it is. All right. Let's look at number 8. All right, number 8 is f of x equals 4 plus cosecant of 1 minus 5 pi fourths x. So let's label our information. This is my k. So that remember that we're going to do 4 plus my y. Cosecant, all right, this is my c, and this is my b, and then there's no a. So again, I would take 4 over 5 pi times my x values. And then for my phase shift, I would do 1 over -5 pi fourths. So if I keep change flip, this ends up just being -4 over 5 pi. Right? And so that's what I would add to my x. So we're going to get some wonky looking numbers once again. I really like it when they give us nice numbers, but it is what it is. All right, so again, old points for cosecant is 0 undefined, pi halves, comma 1, 2 comma undefined, 3 pi halves, comma -1, and 2 pi is undefined. All right, my new points, according to what we just wrote, my x value, I would do 0 times this plus this. So I will be, and again, this means I'm going right. So I need to actually add the positive. So this would be 4/5 pi, comma, undefined. This will now be pi halves times, so we'll do some side work. So take our pi halves times the 4 over 5 pi. So this gives me 2/5, but then I need to add 4 5 pi. So what this does for me is this gives me 2 pi plus 4 over 5 pi. Comma, I need to add 4 to my 1 here. So this is now going to be at 5. And then we just kind of keep going through the process. Again, we should see a pattern here shortly, but this will be pi times 4 over 5 pi. So that just gives me 4/5 plus 4/5 pi. So this will give me 4 pi plus 4 over 5 pi. So I can see now that I'm just going up 2 pi. So that's what I'll do now to finish out my pattern so that I have to do all the extra work. And again, I'm taking -1 plus 4, so that would actually take me to 3. So when I'm looking for a graph, Again, how they go by, they went by numbers again. So looks like they went by, so it was at point 4, point 8, point 12, point 16. Yeah, it went by point fours. So point 4, point 8, point 12, point 16, and then that made it 2. So this was going by point fours. That wasn't already complicated enough. And then we have threes and fives. So 1, 2, 3, 4, 5. All right, so here we go. So then we got to kind of figure out what this is. So let's determine what this is for fifths wise. So we will say 4 divided by parentheses 5 times pi. And we get, this is about 0.25. So we'll just say we're going to add a quarter. So here, if I add a quarter to 0, 0.2 would be about right here. So a little bit past that would be about right there. Right? And that's kind of like the best you got there. And then kind of keep that going. I added 2/5 to that. So I'm going to add 2/5 every time. So I'm going to add 0.4. So that'd basically be 0.65. So here's 0.4, here's 0.8. 0.65 would be about right here. Then 1.05. So that's 4.8 about right here. And then we're going to add another 0.4. So that'd be 1.45. So it's 4, 8, 12, 16. So 14 would be, or 1.45 would be about right here. And that would be at 3. And then we added 4 more to that, and that would give us 8, 5. So that'd be about roughly right here. All right, so pretty difficult to get the actual numbers, but you're looking for a graph that does something like that. All right, let's see. Let's do another one that was wonky. Let's look at number 9. So f of x equals 1 minus cotangent of x minus pi halves. So again, this is my k. I will take my y plus 1. My a is a negative, so that means it will reflect my cotangent across the x-axis. But you'll notice it'll look the same as if I reflected around the y-axis. I don't have a b, but I do have a c. So my phase shift would be negative pi halves divided by 1. So it's just going to be negative pi halves. But then remember, I'm actually going right. So I want to add that a positive pi halves to my x value. So old cold cotangent would give me 0 undefined, pi halves, comma 0, pi, comma undefined, 3 pi halves, comma 0, and 2 pi undefined. So then my new points, see, so for my x value, the only thing I got to do is add pi halves. So this is pi halves, undefined. Pi halves plus pi halves is now pi, and I need to add 1 to my value, so that's 1. This will now be 3 pi halves, comma, undefined. And this will now be 2 pi, comma, 1. And then this would be, well, actually, is technically this a being negative 1 here, you would need to multiply that to your y value. So I need to take negative 1 times y. So really, this is going to be negative 1s. Actually, because if you multiply 0, does it even change? Good question. It wouldn't. Yeah, so it wouldn't. So this part, yeah, because you would multiply -1 first and then add the 1, and it would stay at 1 because you're reflecting. Or you put it at -1, then reflect it, and it goes right back to +1. All right, and this last one, sorry, was 5 pi halves, comma undefined. Always curious about things. All right, so again, when looking for the correct answer, everything basically shifted over. So now, if this is pi halves, this is pi, this is 3 pi halves, this is 2 pi, and this is 5 pi halves. So at pi halves, it would be undefined. At pi, it would be at 1 now. 3 pi halves is undefined. 2 pi, 5 pi halves. So typically a cotangent goes this way, but we're actually going to reflect it to make it look like a tangent. But notice that is where that center point goes rather than at 0. And there you go. So that's pretty much it on that. Let's see. We could probably do a few more. Like to give you as many examples as I can. Let's look at number 10. G of x equals 1 plus tan pi over x minus pi fourths. So again, this is my k, so I'm going to do 1 plus my y. This is my b, so I'm going to do 1 over pi times my x. This is my c, so my phase shift would be pi fourths, technically negative, divided by my pi. If you keep change flip, so this will just give me -1/4. That I would need to add my x, but remember this is to the right. All right, so old tangent would be 0, 0, pi halves, comma, undefined. Sometimes I just get distracted and I can't remember how to spell undefined, or abbreviate it, undefined. All right, so again, this is 0. Now there we go. Define our new ones. Our x, I need to multiply 0 by 1 over pi, so that's 0, and then I need to add 1/4, so I now have a 1/4, comma, 1, because I had to shift up. This will now be pi halves times 1 over pi, so that's going to be 1 over 2 plus 1/4, so that's going to be 3/4, undefined. I like it when they come out as nice clean numbers and not what we saw earlier. All right, then pi times 1 over pi would just be 1. 1 plus 1/4 would give me 5/4. I'm a 1. So again, try to go up. This will again be 3 halves plus 1/4. So I can kind of see a pattern here. So I know this answer is going to be 7/4, but 3 halves is the same thing as 6/4, and then plus 1/4 gives you that 7/4. And then this would be 9/4, comma 1. And then we can easily just graph it. So again, these are going by quarter, so that's what I'm going to go by as well. I think I could have got away with by going by halves. Oh well, it doesn't matter. I've already on this far. So that would be 6, it'd be 7 pi fourths. 8 pi fourths is 2. We'll say this is 9 pi fourths. All right. Okay, so then we just kind of plug in our stuff. So we'll make sure we have a 1 right here. So 1/4, 1, 3/4 undefined, 5/4, 1, 7/4 undefined, 9/4, 1. Again, nothing's abnormal with this, so therefore this would be a regular tangent. So it'd go like this. There you go. And then you would match it to whatever you needed to match. Let's look at number 11. This would be f of x equals 4 plus tangent of x plus 3 pi halves. So again, this is my k. So let's label that with a different color so we can see it. So this is my k. So I would need to do 4 plus my y. I don't have a b. I have a c. So what's my phase shift? This will be 3 halves divided by 1, which is just going to be 3 divided by 2. So I'm actually going to go left. So I need to subtract that from my x. Huh. Yeah, I just realized that most of every example we've done has gone negative. All right. So my old for tangent again is 0, 0. Pi halves undefined. I'm just going to go to u at this point. 3 pi, or sorry, 1 pi is 0. 3 pi over 2 is going to be undefined. And then 2 pi is at 0. Find my new points. Let's see. So for my x, I'm just going to go left. So that's going to be a negative 3 pi over 2. And then add 4. So that's going to be 4. So then 3 pi over 2, or think of it like this. I'm going to take that. So that's going to be negative pi halves, comma, undefined. And then this will be positive. So negative 3 pi. It's going to be negative, but it'll be negative pi because I'm going from a negative 3 pi halves, adding pi. So that'd be that. This will then be negative pi halves. And then 4, this would now be 0 and u. And then this right here would be pi halves and then 4. These are u's. And so now when we graph it, I'm going to actually go on the other side. If I can do a better job here. Go. So this right here would represent pi halves, negative pi halves, negative pi, and negative 3 pi halves. 1, 2, 3, 4. So negative 3 pi halves at 4 would be about right here. Negative pi undefined. Negative pi halves at 4. Zeros undefined. Pi halves at 4. Like this. Again, nothing's negative, so my function would be normal, just raised up. There you go. So let's do, we'll say 2 more, and I think that should be enough. Let's look at number 12. We'll say f of x equals 1 minus 2 secant of 2 pi x. So again, here's my k. So I'm going to do 1 plus my y. Here's my a. So I'm going to do negative 2 times my y. This is my b. I don't have a c, so all I got to do is 1 over 2 pi times my x. So here we go. So old is for secant is 0, 1, pi half undefined, pi negative 1. This one would be 3 pi halves undefined. And then this would be 2 pi 1. New. So let's see. So take that'd be 0. And that's it. So I don't got to add them. A 1, I would do negative 2 plus 1, which would be at negative 1. Yeah, there you go. And so then pi halves times 1 over 2 pi would just give me 1/4. And I don't have to add. So this is now 1/4. And then this would be undefined. That would be 1/2. And then negative 1 times negative 2 is positive 2 plus 1 is 3. And then 3 pi halves, that would be 3/4. undefined, and then this would be just 1. And then again, that's -2 plus 1. That would give me -1. So when we graph this secant here, I'm going to go by fourths. So here's -1, and then 1, 2, 3. Here's 3. All right, so at 0, -1, I got a point. 1/4 is undefined. 1/2 is at 3. 3/4 is undefined. 1 is at -1. All right, so what happens here is, again, here is your secants as such. All right, last one, and then this should give you more than enough examples on how to graph. All right, as always, we label this is my K, so I'll do 2 plus my Y. This is my A, so I'll do 5, 6 times my Y. This is my B, so I would multiply my X by 2. This is, oh, trickery. They're both an X here, so we got to do some little pre-work here. All right, what's actually going on here is if I factor out an X, I actually have a 1/2 minus pi X inside this function. So this is my B, and I actually don't have a C. So this is not a fun problem to finish this off, but we will do it anyways. So this is actually going to be, my B would be, multiply this both by, well, no, I don't got to multiply that by anything. Hold on, I got to multiply this by 2. So this would be 2/2. All right, so that would then give me 2 on top and 1 minus 2 pi on bottom. That would need to multiply my x. Those double x's there means that this whole thing was the b. If that would have been not, this might have actually came out cleaner. So therefore, there's no phase shift. So here we go. So old for secant is, again, 0, 1, pi halves, comma, undefined, 3 pi halves. Nope, I do it every time. Pi would be -1. 3 pi halves is undefined. And 2 pi, oh my goodness. 2 pi would be 1. All right, so my new points. Here we go. So I'm going to take my x. I'm going to multiply that guy. Luckily, that first one stays at 0. And then my 1, I'm going to multiply by 5, 6, and then add 2. 5, 6 plus 2 would be 17 sixths. So again, 6, this would be 12/6, and then you just add. There we go. So then this one here, they're going to go by decimals anyways to ballpark your idea. Yeah. So let's see. So this is going to be pi halves times that guy. The 2's would cancel, so I'm just going to write it like this. I'm going to say pi over 1 minus 2 pi. Because again, when you're multiplying, the 2 would cancel and you're left with just the top. So I'm just going to leave it like that, undefined. And then again, here I would, at pi, gosh, the 2 won't cancel this time. So this time it would be just 2 pi over 1 minus 2 pi. And then this one would now be -5, 6 plus 2. So 12 minus 5 is 7. So this would be 7 6. And then, of course, this would now, hopefully you see a pattern, but this will now be 3 pi over 1 minus 2 pi. And then, of course, this would be undefined. And then this would be 4 pi over 1 minus 2 pi, which will then become 17/6. Now, on the test, or the test, the homework, I think they went by ones or something like that. Or hold on, they went by, I wrote it down. They went by eighths. So basically what that means is this is 1/4, this is 1/2, this is 3/4, and then this would be 1. And then over here, they just went by ones. So 1, 2, 3, 4, 1, 2, 3, 4. All right, so 6/17 is pretty darn close to 3. So at 0, here's 3. I'm gonna go right underneath it, and that's what you're gonna see. So it's gonna be like right below it, and then that's what's gonna happen. Um, this number, actually, I think I wrote the wrong ones down. Yeah, I did. These actually went by halves, not fourths. So this is a half. This would be 1. This would be 3/2, and this would be 2. No, it takes the whole thing away. Oh well. All right, so with just this information, again, that's going to be 0 7/16. And then we can see here that this will be the 1 minus 2 times pi, and then you would do pi divided by the answer, which was like negative 5.24 or something like that, which gives you negative 2.9. So I need to go more this way. So, all right, so here's negative 2. So negative 2.9 would roughly be about right here. Yeah, that would be negative. 1 minus 2 pi. Because it's reflecting. Okay. So here's my undefined. 7/6 is about right here. So here is another 3.14, but it'd be negative still. And what is that value? All right, so hold on. So okay, so let's go back over here. We'll do 2 times pi divided by parentheses 1 minus 2 times pi, close parentheses, and it comes out to negative 1.8. So here we go. So here's negative 1, and negative 18 would be, I don't know, roughly about right there. So 7/16 is slightly above 1, so it'd be right there. The next one would probably be, if I had to guess, about negative 0.18. So that's right here. Well, let's just do it before I guess. All right, so that would be 3 times pi divided by parentheses 1 minus 2 times pi, close parentheses. I don't think it liked my answer. Well, that does make sense. Hold on. I think I typed the first one wrong. Let's try that again. So we'll do pi divided by parentheses 1 minus 2 times pi. I did. All right, so this one's actually negative 5.9. So here is a half. The negative 5.9 would actually be here. Here's your undefined. Negative 1 point something. This is correct. And then this one's actually negative 2 point something. And the next one at 7/16 would roughly be about right over here. So just give you an idea. This is what you're looking for. You just have to use figure out the decimals to kind of figure out exactly where they're at. So that makes it difficult, but again, you don't have to calculate it. You just gotta figure out the correct graph. If you need more examples, let me know. I think this is enough of them though. But reach out if you do. Other than that, see you in the next video.